Hi, my name is Stephen Ennis. In this video, you're going to be seeing 3 of the 5 simulation scenarios that I created using OmNet++ for my master's dissertation. My master's dissertation project focused on CubeSat networks and specifically the power versus throughput trade-off for space-to-ground communications. So if you're not familiar with my work, there should be more information in the description of this video. There's also links there to my ResearchGate profile as well as my GitHub profile and my LinkedIn profile, so you can learn more about my work and what I'm up to at the moment. So we're going to start off with the baseline scenario, which is scenario 1A. So I'm just going to start this simulation moving at full speed and pause it in a couple instances. So you see routes here are represented by dotted lines, and the movement of UDP packets or science data packets are represented by solid lines. So I'm just going to stop it for a second. We can see node master 0, or just master 0 here, has been selected as the GM, and a bunch of links are forming. We can see the cluster architecture very clearly. So we can see that slaves are communicating only to masters, and that masters are forming links between them in order to communicate to ground. So if we continue for a second here, I'm not gonna run these for their entire durations because that can take quite a while. All right, so we're now approaching the point of swap for master 0 and master 3. This is the point at which master 3 becomes the closest master to ground. So D3 is using its default closest master election approach. All right, so there we go. We can see master 0's route is starting to decay. Nodes are now attempting to establish new routes to master 3. You can see we're full of established routes, and packets are flowing again with the new Grandmaster. Okay, I'm going to stop this one right here, and I'm going to move on to the next scenario. All right, you can see we've got the same kind of setup here. I'm not going to run this one for quite as long. We have the same sort of setup. This is scenario 2A in my master's dissertation. In this scenario, the cluster formations of CubeMac have been totally dropped. So although the nodes are still named node master and node slave, there's actually no master-slave relationship. All nodes in the network right now are acting as masters at the MAC layer. At the routing layer with D3 Dymo cubed, only node masters are allowed to talk to ground. So that's still the election pool for the ground master role. All right, so if we run it here, we'll see that they are in fact all acting as masters once route discovery completes. All right, so we're starting to complete route discovery. It's going to take a little bit longer because we have that longer frame in CubeMac's pure TDMA mode. So it'll take roughly 1.5 seconds. Sorry, it will take a multiple of 1.5 seconds to pass all route messages around. Okay, so we can see that we've formed some routes to ground here. It's clear that the cluster architectures are completely gone. So here we have, 3 slaves talking to one another. We have routes forming here, there, and everywhere. However, as I mentioned, the node masters will only be elected to ground master roles, and it uses the same election approach that we just saw. So there's nothing new or novel there. All right, so I'm just going to move straight on to scenario 3. So I'm skipping scenario 1B here and scenario 2B as well. So if you're really excited and interested in my research, I encourage you to give my dissertation a quick read. Okay, so we're still on our first pass. Cut forward a little bit in the video just to save time. And D3 is now using a different election approach. We should see a slightly earlier handoff of the Grandmaster role from node master 0 to node master 3. There we go. So we can see it hands off a few seconds earlier. It's not significantly earlier. This is mostly a result of the fact that this is the first pass we're seeing, and all masters have used roughly the same amount of energy. I'm actually going to continue to run this for just a second to show that we're also not going to get a closest master election approach for node master 1. And there we go. So we see slightly earlier. Now that how early that happens is not fixed, right? So this is a dynamic thing. As the nodes continue to pass over ground and actually loop back and do their second pass and third pass, it can be quite easily seen that node master 0 and node master 2 get rested, right? They have these periods. And actually, if you want to learn more about that, you can see that quite easily in the results presented in my dissertation. Okay, so I guess this has been a promotional video for my master's research. Thank you so much for taking the time to watch it. I hope you enjoyed it. And please feel free to contact me if you have any questions, especially if you want to offer me a really cool job working on space missions. All right, thank you very much. Bye.